Let's try to solve this question here. A submarine that travels in the water at a speed of 8 meters per second and emits a sonar wave of frequency 1400 Hz is approaching another stationary submarine. Okay, let's understand the situation clearly. There's a submarine that is moving towards another submarine. So let's try to sketch that first. Oh, how do we sketch a submarine? A submarine probably, I don't know, submarine looks like what? Submarine. Submarine, okay. This submarine here is traveling in the water at a speed of 8 meters per second. So it's moving at 8 meters per second. It emits a sonar wave. The sonar wave has a frequency of 1400 Hz and it's approaching another submarine. Okay, let's call this submarine A. Then you have another submarine. Let's use another color to represent another submarine. So this submarine here, it's not moving. Okay, let's call it B. 0 meters per second. Stationary, not moving. Okay, given the speed of sound in water is 1530 meters per second, that means that the sound is traveling in the water with a speed of 1530 meters per second. Okay, so right now they ask, calculate the apparent frequency of the incoming wave detected by an observer in the stationary submarine. So that means by our observer is staying at the stationary submarine. So let's draw the observer. Okay, let's assume the human here is special, can live inside water. Okay, so it opens up its ear and listen. Okay, so it opens up its ear and listen, then what frequency will be detected? It's what we want to determine here. Okay, so let's look at question A. For question A, again, let's determine who is moving, who is not moving. We see that the observer is not moving because the observer is stationary because the submarine that is standing on is stationary. So we know that the observer is not moving. So V observer will be equals to 0. So your equation will be simplified to become FA is equals to V plus minus VS F. Okay, second thing you check, you see that it is moving, A is moving towards B. So the distance between them will be decreasing. Okay, so if we know that the distance is decreasing, what does it mean is that your apparent frequency will be greater than the frequency produced by the sound source. So to make your apparent frequency greater, let's determine what sign do we need to put down there. Okay, you want to make the apparent frequency greater, that means the numerator will be larger, the denominator need to be smaller. So to make the denominator smaller, you need to use a minus. You use a minus to make it smaller. So therefore, now you can put in your value inside. Okay, can I just put in like this? Can. Okay, I won't copy it again. I'll just straight put in the value. So the speed of sound in the water will be 1530. Then the speed of the sound source, it's 8 meters per second. The apparent frequency is 1400. So if you do your calculation, you get apparent frequency to be equals to 1407.36 Hz. So you can see that our FA here is definitely greater than our frequency produced by the sound source. Okay, hope everything is clear here. Next, the reflected wave detected by an observer in the approaching submarine. So there will be wave reflected, so means by the sonar wave from A, you hit onto B, then you get reflected back towards A. So that means by the reflected wave will be traveling this way, back towards A. Okay, then of course at A, there's another observer who puts on this here and try to observe what's the frequency detected. Okay, but what we need to make clear is, will it still be 1400 Hertz? That's the question. Okay, this reflected wave, is it still 1400 Hertz? Well, no. Why? Because this person here has already observed a frequency of 1407.36. That means by what arrives at the submarine B is a sound wave, it's a sonar wave with higher frequency. So what reflected off submarine B should also be a frequency that is higher than 1400. So this is the reflected wave frequency actually, because this is what arrived at submarine B. So what reflected off submarine B should be the same as what arrives at submarine B. So we know that the reflected wave frequency, or the frequency of wave produced by the submarine B or reflected off submarine B, should have this frequency 1407.36. Okay, so if we are clear with that, now we'll repeat the same steps to determine the apparent frequency once again. First of all, now who is the observer, who is the sound source? Well, the sonar wave that A is observing, we know for sure that A is observing. Okay, let's write it down. Observer, it's submarine A. This one cannot be debated because our observer is standing on the approaching submarine, and the approaching submarine is submarine A. Okay, but who is the one producing the sound? Sonar wave. Okay, you might be thinking it's submarine A because everything comes from submarine A, but when it arrived at submarine B and we reflected off submarine B, it's another frequency already. Because when you reflected off submarine B, it's another frequency. So it's better for us to say that it is as if the submarine B produced a frequency that is higher than submarine A. Okay, don't worry too much about or reflected off. So the origin, it should originate from submarine A. No, if it's reflected off, but the frequency is really high already, you can straight assume as it is as if submarine B produced a sonar wave. But this submarine B, it produced a sonar wave with a higher frequency than submarine A. You can think of it like that. So if you think of it like that, right now, submarine B will become the source of the sonar wave. So the source of the sonar wave will be submarine B. Okay, so right now, who is not moving? It's the sound source that is not moving, because submarine B, which is the sound source, is not moving. Therefore, we can say that Vs is equal to 0. Because Vs is equal to 0, now equation Fa, let's put prime because it's a new situation right now. So Vs is equal to 0, so now Vo is the one that is need to be filled in. Vs will disappear. So this is the equation. This is the new F, new Fa. This is new F because this is no longer the same 1400 from last time. This is the one that is produced by submarine B, which is 1407.36. Okay, so now we can continue with step 2. We know that sub A and sub B are still getting nearer to each other, so the distance, no matter what, is still decreasing. So because the distance is decreasing, you know that the apparent frequency will have to be greater than the frequency produced. So because Fa is greater, therefore you know that the numerator must be larger than the denominator. Numerator larger, denominator smaller. Only this bracket here be greater than 1, then your apparent frequency is greater than your frequency produced. So that's why you want to make your numerator greater, so equation will be a plus on top, V plus Vo divided by V, then you have your produced frequency. Okay, so a plus just to make the numerator greater. Why make the numerator greater than the denominator? So that we can make the apparent frequency greater than the frequency produced. Okay, so equal substitution again, 1530 plus the observer, which is submarine A, is moving at 8 meters per second, still the same, divide by 1530. Then your new frequency now is 1407.36. So if you calculate it, you get your new apparent frequency to be equals to 1414.71. Okay, so even though the submarine is producing a frequency of 1400 hertz, but what's heard by the person on submarine B is a higher frequency, which is 1407.36. And what's heard reflected off submarine B back towards A is an even higher frequency, that is 1414.71 hertz. Okay, so this change in frequency here is actually very important for people to detect how far is an object from a position. Okay, it is used to detect how fast is an object moving actually, because if you are able to detect the new frequency and you know the frequency produced, from there you are able to determine what's the observer's speed, or you are able to determine what's the sound source speed. So this concept here actually allows us to deduce how fast is an object moving away from us, or how fast is an object moving towards us. And it is very useful in various industries such as aviation. Okay, in aviation they use this to detect how fast is a plane moving. They use this to detect how fast is the fish moving. They use this to detect in medical, they use Doppler also. Doppler ultrasound is a very common method that is used in ultrasound. So many industries or many fields uses Doppler effect to deduce how fast is an object moving. So this is a rough idea how we use the concept here. Okay, that's it for this question. Thank you very much.